I'm Mike Dettinger, and I am a climate scientist and a hydrologist. I kind of spent most of my career in between those two. I love Tahoe for its beauty, the coolness of the air, and the smell of the trees. As a scientist, for me, I always say that Lake Tahoe is one of the few places that I know of in the West where you can see the biogeochemistry happening. I mean, literally, if you look at the color of the lake, or if you happen to be a scientist and are dropping a Secchi disc into it to see how clear the waters are, that's literally seeing the biology, the geology, the chemistry, and how they're faring under the impacts that people have been whacking this basin with for 100+ years. We have to use the past to provide us with lots of analogs as to what the near-term future will bring. But because of the things that humans are doing to this planet, putting lots and lots of greenhouse gases into the atmosphere to warm the atmosphere, we can't rely strictly on that 100 years of record. We have to use models. The best projections at this point are that we'll see somewhere between anywhere from about 6 to 10 degrees Fahrenheit warming of the Tahoe Basin, of the atmosphere in the Tahoe Basin. That may not seem like that much, but think about if your kids spiked a temperature of 6 to 9 degrees Fahrenheit. You would be down to the emergency room in no time flat. That's what we're really dealing with, is that actually any sustained increase like that at those levels is as devastating to the health of this basin as it would be to your kid if he spiked that temperature. In addition to those temperatures, which the greenhouse gases affect directly, as you warm up the atmosphere, it changes our precipitation. It changes whether it's rain versus snow, tilts everything much more towards rain rather than snow, because the atmosphere is warmer, the storms are warmer. That warmer atmosphere also can hold more water, so our storms will tend to be more intense when they happen. The snow that we all draws us to the Tahoe Basin is really going to take it in the shorts in this future that we're projecting. You would expect by the end of the century to see somewhere like 60 to 100% less snowpack, okay? By April 1st, say, take a particular day of the year. The snow season will decline in length. It'll get shorter by somewhere between 2 months and as much as 4 months. We see a future in which our precipitation will tend to fall in either big events or not at all. And so we end up with longer periods between storms that really dump on us. But when those storms that are going to dump on us, they dump a lot. When we get those really huge flows coming down, huge by the local standards flows, coming down these streams again and again in a given year, again and again from year to year, what you end up with is carrying a lot more sediments, you get erosion happening, a lot more nutrients coming with it and flowing into the lake. We've been trying for 50+ years to reduce exactly those inputs. And the climate change is going to be working against that by making a larger fraction of our total stream flow into the lake happen during high flows. It's going to change the character of the lake is the real risk there.